So welcome to chapter number 2, organizing data. This is the first video, and in this chapter we are going to learn what are the variables and what are their types. We're going to learn the different types of data known as the qualitative or quantitative, discrete or continuous, and we're going to learn how to distinguish between a parameter and a statistics. So let's start. So the first thing we need to understand is the individual. When we use this word in everyday life, individual mean the people or the objects. Individual mean the human being, the people. But in statistics, the individual may be the people or objects which are included in a statistical study. What are the variables? Variables are the characteristics of the individual that need to be measured or observed. For example, let's understand this particular table. Let me make a table here. This is the table I'm making. Okay, and let's say in this table I have names, and here I have the age, and here I have the height. Right, let's say I start with mine. My name is Muhammad, right? I write the first one. Age, let's say my age is 54 years old and my height is 67. I have another person, let's say another person, Adam, right? His age is, let's say, 30 years and his height is 70 inches. Now look at this particular table. We have some variables. The variables are, these are the variables which are written as a column heading. The names, the age, the name, age, and the height. These are all the variables, right? And these are the values of the variable. Muhammad, for the first name, the Muhammad is the value of the variable. For the second one, the variable whose age is, the value is 54 and the height is 67. So what is a variable? A variable is a characteristic that vary from person to person or from item to item. And what is the data? I just told you the data is the value of the variable. Okay, there are different types of data. One is called the numerical or a quantitative data. The other one is called categorical or a qualitative data. And there are further types which we are going to learn. The further we have quantitative data as described as a discrete or continuous, and the qualitative data is has further two categories called nominal data and ordinal data. Let's first understand what are the two different types of data. One is the qualitative data. Look at the name, qualitative data. It's a quality. It consists of names or categories that represents the labels, but they doesn't consist of numbers. No numbers in a meaningful way. The examples are, for example, the gender, male, female, survey responses. Let's say somebody asks you, are you happy with the current president's bill which is produced in the assembly? So you may say yes, or somebody say no, or you may say undecided, right? So these are the qualitative nature. They are not numbers at all, right? Next is a quantitative data. As the name suggests, it consists of numbers. Which numbers? With such numbers for which the operation of addition and subtraction or averaging makes sense. For example, the heights of the student in my class. You can add the heights of the student. You can take the average height, the weights of the supermodel. All these are the examples of the quantitative data. So there are two main categories of data. One is the quantitative data and other is the qualitative data. So when I'm saying, you be careful about this, a qualitative versus quantitative. Now there are two further types of a quantitative data. One is called the discrete and the other one is called continuous. Discrete data consists of counts or possible values can be listed. In order to understand the discrete data, you can think it like this. If the values of the data comes into existence as a process of counting, then such a data is called a discrete data. For example, the number of students in my class, you can count them. The number of rooms in my house, you can count them. The number of cars in your family, right? You can count them. These are all the data. These are all data values which can be counted. They have distinct values. Either you have 2 rooms in a house or you have 3 rooms in your house. You don't have a 2.5 rooms in your house, right? There is nothing between 2 and 3. So that it consists of whole values, right? So such a data is called a discrete data. Then we have a continuous data. It's a data that that come into existence as a process of measurement, right? And it results from infinitely many possible values that correspond to some continuous scale that covers a range of values without gap, without interruption or jumps. We use this word in even everyday life, even continuous. You say to your friend, oh, my friend talks to me continuously, which means he talks to you without any gaps, without any interruption, without any jumps, right? So I watched that movie continuously, which means without any break. So the continuous data, if the data come into existence as a process of measurement, then such a data is called continuous data. The examples are, for example, your weight. The heights of the student in my class, the weight of the student in my class. These are all examples of a continuous data. The current temperature, the outside temperature today. This is another example of a continuous data. Why? Because you require, you measure it, right? It comes, the data values comes to you as a process of measurement, right? So one feature which always helped me to understand what is the difference between the two is always like this. I always try to see that whether the data coming to me as a process of counting or as a process of measurement. If the data comes to me as a process of counting, it's a discrete data, and if the data comes to me as a process of measurement, it's always a continuous data. Next, there are 2 types of qualitative data. For example, one is the nominal data, another one is the ordinal data. Let's do for the nominal data. Nominal data, it consists of names or labels or categories, and there's such a categories in which you cannot define any order. You can't say one is greater than the other one, so you can't define any order. For example, the major of the student in my class. They have major, accounting major or business major or healthcare management major. You can't arrange them in any order. Blood group types, for example, you can't arrange them. So such a it's a categorical data in which the order doesn't make any sense. You can't arrange them in any order. Then we have an ordinal data. An ordinal data is a categorical data or a qualitative data in which consists of names or labels, but you can define certain order among the data values. You can define certain arrangement, right? The data values can be, there can be certain order that we can define among the values. But for example, the student letter grade, for example, A, B plus, B, we know that the A is the best grade, and B, then we have a B plus and a B and a C and so on. So these are all, although these are letters, they are not numbers, but we can define certain arrangement. For example, t-shirt sizes. The t-shirt sizes are from small, medium, and large, right? So you can define certain order among these. So these are the 2 types of a qualitative data. Okay. Next, we need to understand what is the difference between a parameter and a statistic. So this is very important that you understand parameter. It's a numerical measure that describes an aspect of a population, right? Any numerical measure that describes something about the population, that can be a population mean, that can be a population size, that can be a population standard deviation. We will learn this in the later chapter. Any numerical measure that describing some aspect of a population is called a parameter. So remember, P, the parameter starts with P and the population starts with P, so that's why P goes with P. Next is a statistic. It's a numerical measure that describes an aspect of a sample. It's still a numerical measure, but it describes not something about the population, but something about a sample, right? For example, a sample mean, sample size, sample standard deviation. These are all aspects, numerical measure that are describing some aspect of a sample. Such a numerical measure is called a statistic. And S goes with S, statistic starts with S, and the sample starts with S. So S goes with S. That's why I have written this S arrow S, right? So it's an easy way to remember. P goes with P and S goes with S. It's just an easy way to remember, right? And second of all, this word statistics, some students think that this is a kind of a typo. Some people think that this is this is a typo, that there is a something missing here, but not. This is a correct spelling. The word is statistic, it's not statistics, so be mindful of that. So let's see an example. Suppose that the percentage of all students on your campus who have a job is 84.9%. This 84.9, this number that belongs to a population. This number is representing a population. Look at this keyword all, right? This number is representing, this 84.9% is representing of something of all. So this means this is a numerical aspect that describe an aspect of a population, hence it's a parameter. And on the other hand, we have a sample of 200. That a sample of 250 students is obtained, and from this sample it was found that 86.4% have a job. This value represents a statistic. Why this value represents a statistic? Because 86.4%, this number that belongs to a sample of 250 people. So this number, this 86.4%, this is a number that belongs to, that describe an aspect of a sample. For this reason, this is an example of a statistics. So this is very important that we understand the difference between a parameter and a statistics. So remember, whenever we are describing some numerical measure of a population, it will be a parameter, and whenever we are describing some numerical aspect of a sample, it will be a statistics. I hope all the things are clear. If you have any question, you can contact me via email. Thank you very much.